The Research and Development Cell of Kannur University, in association with the Internal Quality Assurance Cell, organized a public lecture program on various topics from the 12th to 23rd July 2022. The seventh lecture was on the topic, Is Data Science an Old Wine in New Bottle? And the speaker was Dr. T.V. Ramanathan, Professor Savitribai Phule, Pune University, Maharashtra.
Myself and Professor Sebastian, we did PhD. Of course, I continued to work there as a faculty member with a break of about 10 years. I was with the Reserve Bank for some time, resigned and came back to academics. So this is a governor's bungalow. I'm trying to now say what is this old wine. So the old wine is, like in statistics, so far what we have been doing, or many departments or many researchers, what they try to do is something like this. In the sense that you have, most of the statistics departments were part of mathematics, and then they try to develop models and then do some computation. So basically the development is theoretical and methodology. The basic development is, the theory. So this I have given the years also. All statistics basically developed in 20th century, starting with Fisher at the age of, I think, your age, 19 or 20 years of age. He introduced what is called the maximum likelihood theory. So that's where actually the statistics started, in the sense, and it's all started with applied things. Like he was doing, in fact, he was offered a position at Cambridge, but he did not accept. Instead, he went to Rothamsted experimental station and joined there and started doing agricultural experiments. So the statistics has that kind of a tradition where it's mostly applied and try to solve problems of other discipline. Somewhere we lost in between afterwards. Okay, so that was the development. So what is this old wine? This example which I am going to, Yes. So I am going to show you a slide. There are 3 photographs. This, perhaps you may not be knowing much, but there is one famous personality, whose name is Mikhail Sholokov. And he wrote a famous novel called And Quiet Flows the Dawn. And this was like, it took so many years to complete this, about 12 years to complete this novel. And then it's in Russian, I think it's called Tiki Dawn. And Quiet Flows the Dawn. Dawn nadi vindum shantamai olugunu. So novel is about Cossack life and birth of a new Soviet Union. And he was generally compared with Tolstoy. But somewhere something went wrong. There was he got Nobel Prize for literature in 1965. And then sometime around 1970, there was an article published in Paris. And in that article, it was sort of, pointed the fingers that, is this all belongs to his work, or has he stolen something from somewhere else? And then, Nobel Prizes are given for original works. So there were different type of committees. Different people started looking into that, because once it is given, if it is not original, then there is always a question. So the point is that, some controversy will become a huge controversy if a big person or a big personality jump into the picture and make some comment, which is happening these days also. So somebody will come and make a comment, and that person is nothing but Alexander Solzhenitsyn, who is also the one who is on the right, who is also a literary Nobel Prize winner. And then things have become a big issue. So this is what the article published in Literary Critic D in Paris. They actually alleged that there is another personality whose photograph I have shown earlier, the left-hand side. He has lifted so many things from his work, and that was the allegation. And then this needs to be investigated by the Nobel Laureate Committee. And then this was all, once it's supported by Alexander Solzhenitsyn, who is also a Nobel Prize winner, things have become a big issue. So there are a lot of linguistic analysis. And along with the linguistic analysts, one statistician joined their hand, and that was who was nothing but Niels Hjorth, who is a statistician from Norway. And then, so those days, as I told, what statistician did was collected three corpora of words. And the words, because in any literary writing, there will be a style, there will be a pattern of number of words. So he tried to see that, what is the average number of words that in each sentence written by these three different authors. These three means one is Tiki Don, which is Mikhail Sholokov's, and the other one is corpora from Mikhail Sholokov's other work, and then the Kruikovs. So that is the three corpora, and about 50,000 words. And what they did was very simple, which our BSc statistics students does, how to fit a Poisson distribution for a given data. So try to fit a Poisson distribution. Now Poisson here is not simple Poisson, because you cannot have a word with, sentence without at least one word. So 0 is out. So you have to have a truncated distribution, and then try to fit this and see what is happening with this. So this is the data collected at that time. And then, so we have three, this is like number of words, 1, 6, 11, 1 to 5, 6 to 10 in a sentence. So these many are there in each three categories. And then a distribution is fitted. This is the very simple exercise. And from this, you can see that what is, the first one is Sholokov's work, and second one is Tiki Don, that means the Ancoid Flows the Dawn, that particular novel, and the last one is other Kruikov's work. So it is very clear that the pattern is matching in the first two, which sort of indicate that the work is actually not stolen, because his other work and Tiki Don is having a lot of similarities. Well, this cannot be proved with only this. I told you there were several committees, several people investigated, linguistic experts were there. This is just another side of it, where a statistician tried to come up with a solution. Well, so what is the conclusion? Sholokov authorship of the null hypothesis that D is speculation as an alternative. So this was sort of, this is the final conclusion that you get. So these allegations were not quite correct. It shows that statistically you can, now when you say that you are proving something statistically, it is not like a 2 plus 3 equal to 5. Okay, so don't jump into that kind of a conclusion. We always allow errors. So definitely, that's what I told you, there are so many other people involved in this exercise. Now in statistics, there are various other criteria to decide a model, because who told you that what type of Poisson distribution that one should fit for this data? Because when you have a data and when you try to fit a model for that, definitely a model selection involves. So which model is good? So there are criteria in statistics based on the likelihood theory, and that's what called these abbreviations like AIC, Akai-K information criteria, Bayes information criteria, etc. Well, last couple of years I have been also working on a new criteria called focus information criteria. The difference is that the other criteria are there, which are there in the literature. They go for a very universal type of model without specifying what you actually want to do. So we thought that we should be a little more focused. So if you bring that focus, how your criteria can change, and that's what called FIC. So this is, of course, that's the theoretical side of it. Well, now that problem is solved. The issue is resolved there. Now, this was in sometime in 70s, beginning of 80 or at the end of 70s. So that was old wine. Now I want to see what the current generation people will do with this. Problem is same. So it's the So in the new bottle, how you attempt this issue. So what they do in the current case, I give only two references. In fact, you can do several ways. In the two references which I have given, one is from Stanford and one is another one. The next one is actually from, I think this is from a different, I don't remember the university, but this appeared in Nature, one of the top journals in science. So this Qian He and Shang from Stanford, they say that we can use deep learning for this. Now, deep learning is basically, I mean, like you tried, perhaps you might have heard what is called ANN, artificial neural network. So neural network is basically, you have some input, you have output, and in between it actually associates how this input is connected to the output, and then you can make predictions. I'm not getting into the theory of that. So there are several new methodologies which computer scientists use, nowadays computer scientists use, which are called AIML technique, and which is there everywhere, every walk of life. You have AIML technique. Now what is this AIML technique? So one of them is like, you know, what I have written here is using the network theory. There are different types of network. Unfortunately, I am not getting into all the details of that. One can definitely, I am leaving this presentation. So definitely you can look into that particular paper. You can actually, in fact, there is a problem for statistics or the students to see that the data sets which I mentioned earlier, that you can actually start applying this and see what happens to this. That's actually the problem. So, of course, these guys applies a different data and then they try to come up with authorship. So the problem is same, like you have to have a document and you want to decide who is the author, which is an age-old problem, who the authorship controversy or authorship detection. Now so here they basically apply a couple of methodology for this, what's called Weighted Recurrent Unit Network, LSTM, that is another type of network, and then there is another one called Siamese network. Now keep that aside, because to explain that it takes some time, so I'm not getting into that. But what is the advantage? They say that you have something like 97 to 99.8% accuracy that you can achieve if you use this kind of methodology for this particular problem, in the sense that I will be correct 99.8% of the time, that I will be giving the correct author who actually wrote this piece of document or who actually authored this document. This is what the current people does. Now the question is that if this is the case, now where statistics has gone? Because if you can come up with a 99.8%, then what you have been doing earlier is not, because there you are just trying to support other group of people, linguistic people, by using your distribution theory, which is very basic that we learn, even in BSc as well as in MSc. So what is the distribution? There is some kind of a mechanism that you are, or formalism that you are bringing for any kind of variation as a mathematical function. And then what is that function should be? Well, it could be an Poisson function, e to the power of minus lambda, lambda to the power of x by x factorial. That is what our BSc, MSc students say that. So it has a behavior like this. So you try to verify whether this. So the culture has changed in the sense that you started with that. Okay, you have a data, but you started with that formalism and then try to put your data into that formalism. And here you are not starting with anything. You have the data in front of you and then try to see what is the deciding or governing factors, or in other words, typical terminology is features that control what is called as feature selection. So this is what the current data science methodology does. So the question is that, is it going to affect the whole of statistics discipline? Is that the reason that most of the North American or British universities or top American or European universities change their terminology into statistics and data science? Why this is happening? I mean, like, for example, I think I have a question. When physicists use mathematics, people say, oh, they are using math. Nobody say that they are using number science. Isn't it? I mean, they are using math. And math is needed. But suddenly, when everybody started using statistics, it has become a science, data science. So, what is the problem basically? Right? So that, well, it has a good and bad side of it. So that's what I am trying to come up with. So, well, students have a chance to do this experimentation, learn this, any one of this methodology. It could be a deep learning network, or it could be a slightly below that, like random forest, or perceptron, or anything. I mean, like decision tree. You can use any one of these and then try to see that whether you can use them for authorship detection. There are several papers available publicly in the public domain. Take one of them, or you can take the next one where I've actually pointed out. This is the very latest paper in 2022, appeared in Nature, and they try to sort of suggest an ensemble method which uses a combination of several ML methodology to use this. Same problem is same. They use several different, so the traditional classifiers use this type of problem, logistic regression, support vector machine, multi-depth, then random forest, gradient boosting, multi-layer perceptron. So these are different methodology which are being taught and discussed in the machine learning context. And there's a claim that about 97% accuracy that you can bring in. Well, the question here is, you don't have in the other case it was very clear, somebody has to tell me what random variable I should look at. So I have the idea like, okay, there is every author has a style, and then this author will continue to use the same style, whatever material that he writes. Like the construction of sentences, how many words constitute a sentence? Is he going to use large sentences with large number of words or smaller number of words, etc.? This remain more or less same, and then I look at that as my feature. Whereas, and then we proceed. But here that is not the case. I try to dig out that thing from the data, in the sense that I try to find out the feature or the pattern from the data and then use that feature. That is what called training the data. So that's what basically learning from the data, and then learn and then try to use them. Two different cultures. I'll try to come to the answering that question of my talk towards the end, but I'm just trying to explain them. This is the two different cultures. Now, well, he actually, because he used some ensemble method, and he claimed that this is about 5 to 10% better than the existing some of the other methods. Of course, this paper is not an ultimate of that. It is just an improvement of some of the earlier method, uses a combination of that, and then you get into that. My purpose of quoting this is that, which is as latest as 2022, appeared in Nature, which is supposed to be a top journal, and then this is how the current generation look the problem. And you see how the old wine and the new people look at the problem. Now the question here is, where is statistics here? Are you comparing apples and oranges? No, I am not comparing apples and oranges. Actually, statistics is here. There is statistics, because when you do the feature selection, the methodology, for example, I may use a logistic regression to do the classification. That is a part of regression analysis. Your machine learning, most of the random forest, then the cart, classification and entries, all these are based on the regression. So regression is we teach regression as a model, but regression is basically a classifier. It tells me that you lie here or this side of the plane or the line or whatever it is, that's the one which classifies. So it's like, what happened is that things were there earlier, but it has taken and actually packaged into a new kind of a thing, in the sense that not only that, it is not just a packaging, because of the nature of the data and the nature of the problem has changed. This forced them to change it in this manner. It's nobody's fault. I don't think that there is any fault in statistician or neither cleverness of computer science people. I think it's like, it's bound to happen, and it happened. That's what. So, that's a kind of justification. So now what happens, now of course you should also see the criticism at both ends. In the earlier case, I completely explained, every statistician understood, I am fitting a model and this is how I select, everything was pakka straightforward. Whereas in this case, when you start applying, many of the people don't know actually what is happening inside that. Because most of them, because you have come up with a procedure and then you simply use the procedure. It's like using nowadays, students using packages. Just now I was talking with Dr. Joby, and then he was pointing out I think one candidate answered the question. I think Honorable Vice Chancellor asked him how this happened. He told, yeah, the software did that. I mean, so what is happening is that the blind acceptance of the software is, that's what. So this is actually now everything has to be, why you really want to have a software attached to that. I am coming to that a little later, towards the end of my talk. There is something called reproducible research. What happened that what we were doing was not quite a reproducible research. And now you have to have, the research culture has changed. Whatever research that you do, it should be reproducible. That is why 99% of the journal ask you the details of your algorithm, the details of your codes, the details of your data. Either you put it on a website and give the link, or put it on the journal website. It is mandatory, because I wanted to know what you have done and I want to verify it. I am not willing to buy that argument unless I verify. This is something so that research culture itself has changed because of this. That's what actually it is called reproducible research. And that is why we wanted to know, like the codes, algorithm, etc. Well, because so that I don't want to be in a black box application. Want to be outside that. Well, now I want to see that I also put my hand in this some time back. In 2014, when the elections were announced, elections were held sometime, I think April 4th to May. About almost a month there was election. So we did, with the students, we did a project on, let's take these tweets and then try to make an analysis. Who is having kind of positive sentiment? Well, of course, that time, there is waves. Modi waves, Rahul Gandhi waves, etc. Kejriwal waves. Different kind of waves were there. So we wanted to know what is happening. So we took some, of course, we had some difficult time at that point of time. This is where statisticians find it. That's one of the reasons that, the data science got prominence, because we were little lacking in computation. We were little lacking in managing the, transferring the data or using the software, or understanding the technical side of it. And that is where actually the problem started. So in between, from 1920 onwards, statistics was taken away by theoretical developments more, as opposed to computing. Of course, then you may ask the question, oh sir, but there were a lot of applied statisticians, what they were doing? And is that the same that the current generation data scientists are doing? I would say no. Data scientists are doing little more than what applied statisticians were doing. I'll come to that in a minute. So what we did was, now I'll share with you whatever that we did. So this is what collected data on political parties using such words like, in tweets, how these, positive and negative sentiments appear. So there are several, words that we have used. I just want to show you the picture. So this is the kind of data that we have. Now our students, the formation of the data changed. The form of the data, not formation, the form of the data has changed. Because I didn't have, earlier you may think data means it's a raw column data. No, data could be anything. Because you know how much data that you have been producing by sending messages, your WhatsApp, everything is data, your Facebook, everything is data. So the data is, like the nature of the data got changed. It need not be raw column, structured, it could be unstructured. So this is a kind of unstructured data where there are only tweets, and then you would like to know what is the sentiment of the people. Of course, this is very limited. It is limited to people who use Twitter, and mostly it is limited to kind of urban, because those days it was not that kind of popular. So what we got was like collected tweets and provide a dictionary of positive and negative words, which we have to see. That is what basically. So there is statistic. There is a feature. What is the feature? How you classify the sentiments as positive and negative? So this is called, there are some linguistic things, PTNT ratio, positive tweets, negative tweets ratio, etc. So I wanted to show you a picture which is there, which we came up with. So this shows during that April month, about 25 days, this is where we collected the tweets. And this is how the sentiments were changing over the days. So you can see that the blue color was the Rahul Gandhi's, and then the red was this Modi's, and then of course that one was Kejriwal. So this is, of course, this is like this is not the actual thing, because I am not claiming this is the actual thing. What I am claiming is these are based on the tweets. What are the positive trend and negative tweets, and then how it changes over a period of 1 month. Well, that time we have to, even though the research was about 3 months, about 2.5 months we spent how to collect this data from Twitter, convert them, because we were not experts, to be very frank. We don't know. So actually me and my students had a very tough time. But somehow, with the help of some people, we could manage that show, and then finally, we were good at statistics. This was the problem with statistics. So the takeaway, is that you have to upgrade your skill with computing. You have to upgrade your skill with IT techniques. That is badly needed. Well, let me show you another picture. This is about the parties at that time. So you can see the wave. Like the party wave was visible also, at that point of time. And this is another, of course, we don't want to restrict. Actually, what we thought that my basic interest is not in politics or social science. My interest was in finance, because I had some amount of time spent in Reserve Bank. So I wanted to study the financial markets using these tweets. But then once election is announced, everything is sort of not with a high variation, because there are restrictions. So so not much of things were going on in the financial market as well, because unless you bring in new policies, new decisions, then only the changes will be visible. So it was sort of stagnant. So we dropped that data at that point of time, and then so we thought that we should look at another one. Can you predict the success of a Bollywood movie? So that time there was a movie called Two States, which was a hit by, I think, Arjun Kapoor and Alia Bhatt. So that was a hit at that time. Of course, before movie was released on 16th, I think, we had data from 1st of April to even 1 week after the release of the movie, and then try to analyze the tweets. Actually, it clearly shows this is so you can even predict the success. What is the mood of the people about a movie which is going to be released, and then how people sort of going to receive it. So what will it going to be a box office success or not? So this is like a simple example where your data form is changed, your questions are changed as compared to the usual raw column data analysis. So this is where the data science is getting changed. This requires a lot of computational knowledge and new things, as opposed to what we learned or we have been doing. So that's the reason that most of the statistics department across the world is now trying to see that it's not that something is lost completely. No. Because if I am doing in a medical context, if I am conducting an experiment and I am doing a small sample test, a Fisher's score test, I may require, I need to, which is there very popular in survival analysis. I will be doing as usual, the usual kind of statistics that I have been doing. So nothing is lost, but the nature of the data, and the requirement, I have a special terminology for that. What is required is that the common demand has changed, and that actually, changed the whole thing. Well, I think I can skip this. So The one view was like, you have what I told, there is distribution, there is model, and small to mid-sized samples, and emphasis on significance, fitting data to models. And that's what most of us do the research. And like you have a hammer, and then you are searching for the nail. Where my method can be applied for a data? Actually, when I read papers for reviewing, I mean, like I see the difficulty of the writer to find a data which fits his model. But I mean, every one of us experienced that, including me also. I mean, but now things have changed. I mean, that should not be the way. You should look in a different way. Like you should try to solve a problem from practical point of view, and then see that what is the model. So this is like with a hammer looking for a nail. And this was there earlier also, because applied statisticians were doing, they were doing data analysis, which is data based, and then you say emphasis should be on relevance, fitting models to the data, and then computing help to generate some kind of a hypothesis, identify features from this data. So this is slight, and this has been, so this data analysis component was there, but this has been now came up with more additions to that, and more broader look into that, and that is what basically nowadays what we see as a data science. So computation, we had doing statistics using computer-based model, and statistical computing is providing computational tools for statistics by using tools and techniques from computer science. So this is like, now you see a couple of things which I just denote, I mean that this is for students. I mean, what can be done without a computer? You can do simple testing, models, graphics, which I think that today is that Poisson fitting. Perhaps you can do it even without a computer. If of course truncated Poisson may be slightly involved compared to a simple Poisson. But still, and what can be done better with a computer? Test, model, graphics. Graphics that comes part of visualization. Because the current generation is tuned to seeing the things. So you need to have visual effect as opposed to the numerical facts. So visually how you can portray the result. This is very important these days. Now what can be done without a computer, and then the advanced cannot be done without a computer. That learning from the data you can't do without a computer. That's where the current data science is actually prominent. So I already told you about visualization. So do computer scientists steal the show from statisticians? That's the question. Because they have better, you might have heard these buzzwords. So better marketing, better database savvy, better packaging, more general. Well, so is data science shifting away from statistics? I would say it's not really, but somewhere or other you have to go with what is that needed. So how much time I am having? I can. Okay. So the data science, so the difference between the statistician and data science, one who developed the theory, practiced the science of collecting, analyzing and interpreting the numerical data. Very clear, that is, it was like numerical, but then if you look at the second sentence, one who uses the scientific method to liberate and create meaning from raw data, any form of data. It could be pictures, sentences, text, numerical numbers as well. So you need to, that's the difference. So the statistics profession is caught at a confusing moment. The activities that preoccupied it over the centuries are now in limelight. Now in limelight because our students get jobs. You see, our, for example, where I am working, the department, we have almost 100% placement for statistics students. And this has been the case from almost last, I would say 20 years, except for the COVID period. Now, all these students are not great students. I mean, I would say less than 50% is like above, just average students. But they get job because you need, so that's what it is. So, but those activities are claimed to be bright, shiny, new and carried out by upstarts and strangers. Because everybody can do this and they actually need people to support them. And that's where, so even our below average students get placed from campus itself. So this is something which we all should think of. In this context, I would like to share with you some of the things. CFJ Wu was a professor in Michigan State and now he moved to Georgia Tech. and he's a very expert in experimental design. He said once that this data science is nothing rebranding statistics. Now, this is, I already told you why physics, when they do mathematics, they don't say they are doing number science, they are doing math. But when people started using numbers, then suddenly it became data science. Well, there are some memes like big data, skills, and jobs. I think these memes are really correct because, as I told you, the nature of the data changed. And then the job, see, what is the purpose of this education? I mean, somebody should have a good job. Of course, definitely there is an academic interest into that, but then we don't want everybody to be an academician. So we want a lot of people to be, I mean, their education should give them bread and butter. So if industry is demanding that, I don't find anything harm in that, compromising your math. You can come, of course, I'm a typical mathematician. I mean, I learned most of my MSc, I mean, more mathematics than statistics at that time in Karivattam. But over the period, things have changed. So if there is a change, why don't we also adopt that change? I'm not against that. Well, if somebody wants to have fancy about math, let him learn that. So make an opportunity that so that you have. So these are, even though these are called memes, I would say these are not necessary memes. I mean, these are basically, one can say that this is the reality. Now you may wonder, oh, but statisticians, if they think that they are all great, I mean, they have contributed, why these people didn't realize this earlier? Well, this was realized by many statisticians at that time itself. In 1960, in around 60s, John Tukey, he said that an era is going to come like this, where what people are doing now is becoming slowly redundant. And what is that going to come? That time he called it as EDA, exploratory data analysis. Well, computers were growing at that time. I mean, that IT was growing at that time. So he was saying that, I mean, something like today's data science moment would be coming. And he quoted this in one of his articles, Future of Data Analysis. Something more than what applied statisticians do. That's what I said. It's not simply a data analysis or applied statistician what do. You have to have a much broader outlook. What does we mean by broader? Even applied statistician at that time tried to look at data and then give an answer to the questions. But now it is not that. What you have now, I will have it in the next or two slides. So Tukey identified 4 driving forces of the new science. There are formal theories, accelerating developments in computers and display storage devices, which is very much needed, because if you want to use the data, you need this. And that's how, your the things which in your hand is so powerful, which many people know. In fact, there is a book, I would say that people use this big data or high dimensional or data for wrong things also. Perhaps you maybe heard that there is a book called Weapons of Math Destruction. Not mass destruction, math. Weapons of Math Destruction. So you should read that. Plainly readable book, which is basically tell what is the wrong about this kind of big data or data driven conclusions. So, well, we have seen that what happened to, somewhere it can go also wrong, like what happened to Google in terms of Google Trends. While identifying the pandemic, influenza, Google used who is surfing what, who is actually searching what. I mean, doctor, temperature, paracetamol. So they tried to see that, but actually, what has happened, that it actually went wrong. I mean, well, you can read, that is also a paper appeared in Nature about Google Trend so the statistics profession faces choices in future research between continuing concentration on traditional topics based largely on data analysis supported by mathematical statistics, and a broader viewpoint based on an inclusive concept of learning from the data. The latter course presents severe challenges as well as exciting opportunities. The former risk seeing statistics becoming increasingly by marginal. And this is what happened. In fact, when I was reading an article, I saw that in 2015, Michigan State University had one of the largest hiring, 35 faculty members they hired in data science by spending millions of dollars in one go. That's the highest ever Michigan State did in one go. In one go. Now, why suddenly? Because they think that this is going to stick for at least another 50 to 60 years. And that's what is happening. So they realize that the importance of this particular discipline or this person. In fact, this person is all you may be knowing R language. R language is nothing but a public version of S language, which is actually more what I call is that structured and more professional. I mean, compared to R is like freeware. This is not freeware. So this person is John Chambers. He is the one who is saying this. So I give you another example. Perhaps Berkeley, there was a biggest probabilist called Leo Breiman, who was actually a student of Michael Lowe, who was one of the top probabilists. Perhaps those who have done MSc, they know the Lowe's book on probability theory. And Leo Breiman in 2001, he changed, and you won't believe that he is the one who invented random forest. He completely changed from the probability theory to this data science, and he is the one who actually invented random forest as well as CART, classification and regression trees, which is the backbone of your all ML. So you see the change. So you see, so statistics starts with data. Think of the data as being generated by black box, in which a vector of inputs variable x go in one side, and on the other side you have a response coming out, and inside the black box nature works, and then see that associate the predictor variable with the response variable, and that's what this is Leo Breiman's statement. So there are two goals basically. So he actually changed this statistics as two kind of a thing. One is inference and one is prediction. And this prediction part was not part of earlier statisticians. They were doing a lot of inference. They come up with, try to understand the behavior. But what is needed is not just understanding. You need to say what is going to happen. So that is where the predictions, so that is where, the data science is actually dominating. So there are two cultures, and this inference to infer how the nature is associating the response variable. Well, that is also important, but what is more required is to be able to predict what the responses are going to be in future input variables. And most of the data science applications are concerned with second one. Of course, there are some traditional statisticians who were a bit against these ideas. These ideas were of Leo Breiman and David Cox and Efron. Efron is also considered as a top statistician, Guy Medal Award winner. So they had a little bit of difference of opinion on making everything on prediction or depending everything on prediction. Now it has gone to industry 4.0, industry now 5.0 is coming, where prediction is going to be prescription. So it is not just prediction, you are going to prescribe, and that is what come in the medical terminologies or medicines, as well as not only in medicine, your recommended system. Your recommended system is nothing but prescription. It is See, you open Google for checking a hotel. Next time when you open the Google, you will get all hotels on the screen, on the side of the screen, whatever you open. Why it is coming like that? There is a recommended system is working behind, and it says that, oh, you are looking for this, so we will recommend you this. It may not be directly coming to you, but that's what it is. Many things, you can go and experiment with the Google, you just see that as if you are making a booking in Make My Trip or something like that, and next time you open, you start getting all these things. So it is learning that and try to give you suggestions, and that's what prescription. So from prediction, it is now moving to what is called prescriptive system or prescription. So this is, in fact, many of the IBM and the companies is moving in this direction from prediction to prescription slowly. Okay, this is the terminology what I mentioned, the common task framework. So if you have a common task framework, you can keep your maths aside and then achieve that tag. What is the task that you are looking for? So that's what Netflix did. Netflix want to know what should I recommend to the people, and that was $1 million challenge. And then some I forgot the name of that gentleman who actually cracked this and then gave a suggestion to the Netflix, even though Netflix didn't use that. It's based on the data, like past, what was the choice of the people. So this was suggested by that, and I already mentioned about Google Trend, and this is the reference, so people can actually look into this. So you can say that the activities of the data, so why I said it is beyond data analysis, because this involves many things. Data gathering, preparation, because gathering itself is a big challenge here. As I told you, for my experiment which I tried, it was difficult how to convert that data, text data to a numbers. So how will you can actually do this exercise? So visualization and presentation, all these are very important. This is for students. Now students may think that, oh, this is all computer science. No, you need very core maths also to become a, data scientist, to become a data scientist, because you need a lot of matrix algebra as well as functional analysis. Why? Because you want to now understand in the neural network or whatever, the optimization problem that you are dealing, it requires this. So you can't be a person who is just prescribing a medicine, without knowing what is he doing. But you need to know that. So if you want to be a good data scientist, you have to have math. So don't think that maths is important, is gone. It is there. You need to have stats. Because, see, that is what the next couple of blue lines. The first one is red, then the blue. Then what is required is the green, computing. So you need all machine learning or all kinds of computational things. And then this is not enough. Now you need to understand what other people want. Because if you don't understand their question, then you cannot be a solution provider. So you need to understand what others talked, what others wanted, what they are looking for. So that is where domain knowledge is also important. So data science is basically not a single person does everything. It has to be a team. Okay, it has to be a team, and then you also understand what others speak. So what I would suggest that at least in Kannur University, you should have an opportunity to speak statistics, or you just go and talk to other department students what they are doing. Can I help you in statistics? You will learn what they are doing, and that will give you an opportunity to use your, at least as a beginning. So this is something that one can think about, or you can even assign this as a compulsory thing for students to do. Talk to your other department people. See what way you will be helpful for them. This is very much needed, because mostly it's said that statistics is for others, not for themselves. So these are the skills that you require. And communication, of course. You have to communicate what is required and what needs to be told. Because otherwise, it is very difficult in these days. Because, I don't have to give examples. One of the biggest communicators in our country. So there are a lot of, without communication is very important. You need to communicate what you are doing. So tell them that this is how it's to be done. And so you need to understand. So develop that from the beginning. 2 years of your MSc, you should actually spend. I am not talking on data scientists, doesn't mean that only statistics people can be data scientists. For example, in Pune ISER, there is a data science department, there are only 2 faculty members. One of them is a TIFR maths fellow, another one is a National Chemical Laboratory chemistry fellow. And they are the data scientists. No statisticians. No, of course, I am interacting with them, but so it doesn't mean that you have to be what is required is statistics. Still you can understand, you can learn. So it is actually a teamwork. What is required is that, so the chemical person actually does a lot of data science related to the chemical or biochemistry and chemistry. The maths guy, I will come to that, what maths guy is doing, and then it is interesting. Well, so this is what I said. This is taken from the internet. So you can see, and I found it quite useful. So this is domain experts, and you need data science means it is something like this. Now there are some, one has to be careful. It's not just, as I told you, you cannot be a black box provider. You need to know. And research side, if you are doing something, it has to be a reproducible research. So this is basically data science research. Reproducibility is, uh, I think those who are writing papers these days, journals ask for codes and algorithm, which is must, which was not the case when we were doing PhD or even in the beginning of 90s. But now that is not the case. Now without that you can't even publish anything. Everybody want reproducible research. So it has to be reproduced. So this is what concept of reproducible research. So that scientific methods have to be validated empirically. It has to be reproducible, and mathematical derivations and proof will not trump conclusions derived from state-of-art empiricism. So this empiricism has come and then trying to encroach into the other side. So the scope and impact of data science will expand enormously in coming decade as scientific data and data from any domain are available in plenty. In fact, that is one of the reasons. Earlier data collection was a big job. Now, perhaps I think you know that now this fast tag business. You cross a toll, your entire life history is going to be captured there. RFID captures life history in the sense, what is your name, what is your car, when it was registered, what is the make, etc. Your chassis number, engine number, all these details in one scanning. One scanning. And that too, you are not even waiting for that to scan. You just pass, captured. This is how the data collection is. So you imagine which was so difficult earlier days with this much form you have to ask people to write. So the nature has changed and we need to change accordingly. Okay. So this is, now some of the other, since I am actually a kind of academician and doing research, I wanted to share, in the next 5 minutes, I'll share some of the work that I had done. But these are not data science related. But I was, I also trained like a traditional statistician, so I was like doing the first type kind of a thing. But I had an inclination towards applied things. So one of the things that perhaps I don't know whether how many of you know, in 2009, there was a kind of, H1N1, this influenza, which came from Mexico. There is a place called La Gloria. So in the world, first H1N1 came in Mexico, next one in Pune. And it's like COVID came to Thrissur from China. So like that, this came from Pune. But that time there was no tracking, and also how it came, nobody knows. But National Institute of Virology, which is located in Pune, and there was no testing things available publicly. So like, COVID testing, initially with the government sector. And this was also with the National Institute of Virology only. So they only test and they only give the result. They only have the kit available. So they have data for 3 months on daily number of positive cases. This is the only data that they have. And they wanted to now give a prediction how serious this is going to be. So the cases are, I don't have the graph here, but you can Google it. Actually in some of my publication it is there. Initially it was like 1 case, 2 case, etc. And suddenly it has gone to 99, 100, 200 cases. And that is the time Pune went for a lockdown of about 10 days. Entire cinema theaters, malls, schools, everything was closed in Pune. And then it came back. And then this National Institute of Virology wanted to know, is it going to come back again? Or is it kind of going to be coming back next year? Or what is the kind of, nowadays we call it as R0. R0 has become suddenly very popular these days. Everybody wanted to know what is R0 because in newspaper, everywhere, because of the COVID, so many papers, almost 25,000 papers are written in scientific journal about R0 calculation using different models. Well, so here the interest is like, NIV people just wanted to know, is it going to come? So we had a team, like 4 people started working on this. Very simple data, we have only number of positive cases, nothing else, okay. And then about 70 days, 3 months roughly, 75 days. And this data and our conclusions were like, it has a reproducibility in the sense that we actually applied a time series kind of a thing, integer time series. In that I couldn't find much of the things, but there was another stochastic process, what is called branching processes. So we applied branching processes and then tried to see that is it, what is the kind of, in branching process there is something called reproducing that effect. So there is a offspring distribution and the rate of reproducibility, the mean of that offspring distribution. So we tried to find and estimate this. We told the NIV that currently this kind of R naught is about 3, which is much larger than any of the influenza, and the probability that it come back is like branching process. We have a calculation of probability. What is the probability that branching process extinct? Perhaps those who teach stochastic process, they know. And we found that the probability that this is going to come back is about 0.65, which means that this H1N1 is going to come back again. Well, I'm not getting into the technicalities. So this is the research. What happened that because we have an understanding with the government institute, all the report was given to them, and then they just took them to the government, Delhi and all, and then it was like, we don't know really what has happened, because were not allowed to publish anything on that directly. But subsequently, we learned a lot of things, because forget that, because government institutes have some problem. They also change the data. Once because this value was quite large, they came back, the director came back and said, no, there was some problem with the data. We wanted to change it. I thought, okay, maybe there is some problem with them, and then change it. But that number was so high, so that is why he was panicked and he went to Health Ministry, Delhi, and things like that. This was in 2009. Okay. Well, this was only in Pune. That is one research, and we could produce a PhD afterwards on applying or developing what is called as two-state branching processes. And then of course we wrote a couple of papers on integer time series later, in which some examples from this data was given. Well, another one of interest, my interest is like, again, it is a bit of academic interest. I have some interest in finance, and perhaps because of the advancement of technology, how many, perhaps if you have looked at the stock markets, if you look at NSE, BSE, National Stock Exchange, and Bombay Stock Exchange, what do you see as a public data is like the closing price of a stock, the opening price of a stock, or an average price of a stock, sometime hourly price. This is the data that is given. But this is not the data actually. The actual data, especially in NSE, NSE is a completely computerized system. Actual data is a high frequency data. For example, in 2019, the November month, we had 19 days data. One of the days, Reliance stock was actually sold and bought almost more than 1 lakh time in 24 hours. Now, this 1 lakh time, you have asking price, you have selling price, and settlement price, and quantity, how many stocks that you have been selling. It's a huge data. This is called high frequency data. And such data, if you think of who is using that, investment finance companies, and they want to make their policies based on that, not you and me. Of course, some institute like IGDI or Indira Gandhi Institute of Development Research, some of the IIMs, some of the IIT, they have a understanding with the NSE, National Stock Exchange, and they would also get this counter opened so that they get this data. Well, others have to pay huge money. You can just open the NSE website and see what is the price for that. Its price is going in lakhs. Like if you want one particular counter or couple of counters, it may cost you something like 10 to 12 or 15 or 40 lakhs. So that's how they make money on selling this data. Now we had to write to them, and then I had a project, and then we got this data 1 year prior, because investment companies don't want prior, they want current, today's data. So even they want morning's data so that they can tell something, because I do some business in the morning and make some money in the afternoon, isn't it? That's you and me making not 1 rupee. Investment companies are that in terms of millions. So that's the difference. So investment bankers, they are, especially bank and financial institutions, it will be in terms of like, the amount is, so even if you 10 paise, 20 paise profit, you multiply in terms of lakhs, that will be a huge amount. So that's what called high frequency data. Ordinary statistical methods are not enough there, because the nature of data changed. And one student did PhD on this, how to do the analysis relating to this, especially on modeling and other things. Another one is like recently I had a paper, not big data. It's like some of the, there is some concept in economics, what they call efficiency of a system. So if you have several systems, you have inputs, you have output. How efficiently you make use of the input to bring the output. Then you may ask, oh, that is an optimization problem. What is so great in that? Well, it is an optimization problem, but what is happening is that these days, most of the optimization problem initially start with a deterministic nature. And if you try to see that, if you want to bring in a stochasticity to that, and that's what called a stochastic optimization problem. So we looked from that angle. So I had some application of, crime, what is the number of crimes happened in each state, and then see that how you can see that how efficient different states are handling the crimes. So there is a paper published in Journal of Quantitative Economics, which published very recently. So that is another work. Well, there is no data science per se in that. Now comes to the last one, where this is how the branding matters. So I had a chance to talk to this ICER TIFR maths guy. So I asked him, first time when we have interacted, what are you doing? Well, I do data assimilation. My God, then I was wondering, what is this data assimilation? So I never heard about this. So I am being like a professor, I never heard data assimilation. So I found it a bit odd. So I told, okay, fine. Then I came back. Then I looked at that. What is this data assimilation? Then I realized that data assimilation is nothing. It's like, you have some data, what is called as dynamic system. Dynamic system is like, you are observing something, but this is being controlled by another system. This controlling system, you don't have the data, what you observe. So this is called the system, the system state equation, and there is a system equation. So there are two equations. Equation need not be linear, it could be highly non-linear, non-Gaussian. And this is the kind of data. And what he does is that at every stage, you have to update your knowledge. And that is called data assimilation. That is where I told you, packaging the things in a different way. So what he was doing, so I told, no, I have a student who is working on, orbit determination of satellites. I have physics, who's a scientist in ISRO. We're doing PhD in orbit determination. How do you use statistics to determine the orbits of a satellite? Because the advantage of that is if you some places when you are inside a cave or underground or some buildings, you don't get the GPS signals properly. In such a case, if you have a local mechanism to predict the orbits, then your the positioning can be done much better ways. So there you don't have the actual positioning; it is done based on a prediction. How this is done? So the idea there is like orbit prediction is statistically you can do the orbit prediction. And for doing the statistical orbit prediction, what you are using is nothing but dynamic linear system. And in that dynamic linear system, dynamic systems, not linear, because these are not linear and non-Gaussian. So there are some methods. Perhaps those who have done advanced time series, what you call it as Kalman filter, and much modern or more generalized version of that is called particle filter. And I was doing that and the student was doing that, but I couldn't say that this is not the data assimilation which he was talking about. The thing is that rebranding the things in a nice words is also matters these days. So you have to package in a different way and then sell it. And maybe statisticians are not good at that. And that's where you are being little sidelined. I think you should come up and then rebrand yourself so that you also have a lot of things to say. I think I'm almost done. Next couple of slides are some technical things I'm not getting to. I think it's the best time to stop. Thank you very much for inviting. Questions if you have any.
Thank you, sir. Now the session is open for discussion. You may ask your questions.
So good morning, sir. Yeah, of course, it's a very enlightening talk, especially I'm from computer science background. So, yeah, most of the times I think when we, so basically when we discuss about AI and ML, we used to discuss with Sebastian sir and Joby sir about, this is nothing but statistics. We do agree the fact. But don't you think that, especially if you take the problems like neural network, which you have, you are giving an input and you are taking an output, where you are trying to find out what are the weight metrics in between that. But of course, it is not computationally possible for a human being to do it, right? I mean,
Right.
taking a paper and pen,
Right.
it's not possible.
Right.
But nowadays it become very popular, it's only because of the computational power, nothing else. Because the phone
Right.
I am holding is having 2.0 gigahertz processor, which I could not even think about when I was doing my graduation, because that time the processor capacity was only 400 megahertz,
Right.
where I cannot even think about running a neural network in a normal desktop computers,
Right.
right?
Right.
So instead of, can we make a statement in such a way that, like this age-old mathematics, like statistics, whatever you said, it become more popular only because of the computational power. Do you agree that fact or not?
Yeah, agree. There's no, I mean, not only because, many things, like for example, I can give you an example. Yeah, I understood your problem. I'll tell you another very interesting thing. This is for the computer students, like I mean a math student or statistics student. You have the Bayesian inference. The Bayesian inference was basically, what is this Bayesian inference? You have knowledge and you can update your current knowledge. Because for example, see, when you see the notice of this particular seminar, you thought that what is this guy is going to come and talk? Now you have sat here for 1 hour, you have some update of, this is what he is trying to talk. So it's called updation because you got the data and you updated. Now, for example, when you see another pamphlet of, I'm going to talk something, you say, this is what he talked. So this is what called updation. This is exactly what you do in a Bayesian. Now, what has happened that this Bayesian analysis was there in the statistics, but what the problem was that if you look at the math side of it, this updation requires what is called to computation of posterior, in the sense that you have a prior, you assume what kind of belief that I have. You improve your belief using your data, because the data basically come and substantiate your belief or improve your belief, and you get the posterior. Very simple thing, I mean, but when you put in the maths of that, the maths become more complex. And because the maths is complex, people could not compute the posterior many a time. And that's where Bayesian becoming dormant. It was actually 200 years prior to this. This idea was there, Bayes theorem was much earlier. Professor Sebastian is applying, Joby sir is applying, there are a lot of Bayesian work in this department. But why this was dormant at that time? Because you don't have computational power. So computational power did not help not only MathStat, it helped the entire thing. That is what it's like, how your MRI analysis has become so, so it's not only, I can predict better things. In fact, in our department, there is a workshop going on last 4 days, R for omics data. So omics, in the sense, omics is nothing but, you have genomics, you have, lipidomics, you have, what is that? Metabolomics, yeah, metabolomics, and all this data which was not possible to, acquire in an easy manner and transfer is now becoming possible. So I don't have any, hesitation in approving that this thing is like, it's not just for MathStat, it's for everything. So the computational things have changed the life actually. See, you yourself agree that when, you tell, my 10-year-old children these days, if you say that 10 or 15-year-old, you are offering them a mobile phone, immediately they will say, what is the capacity? Did we ask such question at that point of time when we just had, no, because they are aware how much data, how much photos to be loaded into that. So I need 128 GB. So things have changed. Our approach has changed. So I don't have any hesitation. I mean, in saying that, that's the one which is saying. You don't have to be compartmentalized. I would say every science actually work for each other and then bring new knowledge, and that's how it is. So IT has helped every science. Why, why only this? I am talking about linguistics. My example is in linguistics. And that's just because if the data is huge and there is a course, I don't know whether you are aware, our students, there is a course called Natural Language Processing. How your Google Translate your whatever that you say, how do you do that? So there is this is the advancement of, technology. So technology has brought in a lot of data. That needs a lot of changes in every work of analysis of data, and that is what the data science is all about. I don't feel ashamed of that. If you ask me the question, old one in new bottle, I am not trying to justify. Actually, I would say both are needed and both should support each other. The reason is that meme, for example, the nature of the data has become huge, the nature of collection of the data has become different, so that you also need how to address. So earlier we were interested in more specific question, but now I am interested in more in classification and clustering, because I am not interested in specific questions anymore. I just wanted to know how many people agree or which are the categories, so that later we can think of that specific question subsequently. So that's what I told jobs. See, the three memes works on that. Jobs, the data, the bigness of the data, and the IT development.
Okay, hello.
Yeah.
My question is, like industry 4, science have also have four paradigms. The first one is empirical science, second one is theoretical science, and third one is simulation-centric science. But there is a paradigm shift in simulation-centric science to e-science because of there is no correct, because the nature is not deterministic. So that we cannot explicit nature in terms of differential equations. So we start. So that is the starting point of data science. That means the Stephen Wolfram first predict there is a new kind of science, that is what e-science come. So it is the correct point that we are arguing that relevance of data science come because the technology also comes. So the evolution of data science can be explained in this way or not?
I'll just say, because you said that there are so many differential equations and they may not be, the environment or the nature play on that. That is what, and make it stochastic. That's where statistics comes. When it becomes, then you have to deal with this differential equation as stochastic differential equation, which is controlled by a process. Isn't it? All the stochastic differential equation is subject to derived from a particular process. So you need a Gaussian process or general Levy process or any stationary or jump processes. So the point that we are trying to say that is where I need from deterministic equations to stochastic equations, and that's where the whole of physics and maths basically start with thinking that there are a lot of deterministic things, except for see, it all started with all your physics thing basically start with Newton and this, but then subsequently your Boltzmann, what is that Boltzmann statistics thing coming to play, think that it is not stationary, there is a statistical aspect of that, and then now it has then they thought that no, it is much beyond that, and went to the quantum, and and if you look at the failure, definitely failure is there at every stage, and then you try to substantiate or support that. So I would say that, well, stochastic part is there, and if you identify, we need to actually move from that, because we start thinking, most of the process that we are considering needs to be not just deterministic. I have to incorporate other factors, and because I can't compute a stochastic integral equation if you think of when I was doing MSc or PhD at that time, but now still integrals can be calculated like so accurately. So what is there? I mean, like in any integration, I can just do it, and that's what it is. That's the power. So but I'm not forfeiting the earlier thing, because it is governed by a process. So I need to follow that assumption model. So that is where statistics comes, because when you say that it is controlled by a Gaussian process, I have to justify it. So I think I myself told the orbit determination, all the equations which comes, they are not Gaussian. So I have to first test this data with the data, that how the assumption of Gaussianity is true. So if it is not true, then we need to have, change the approach accordingly. So statistics is there. It's not that it is not there. Model is there. It's not that model is not there. But at the same time, it's like, what is needed, and then we need to provide accordingly. That's what I would say. Your astrostatistics has a lot of application of AIML because the data is so huge, unstructured, and not even time structured. See, time series is basically, it attached the time, whereas here this time is there, but they are not equispaced. So how do you actually analyze? Your standard time series analysis will not work. Standard time series analysis say that your observations are equispaced. So if it is not, which is the main thing in astrostatistics or astronomy, entire your IUCA does that.
Thank you, Professor Ramanathan, for such an insightful talk. I'm not from a data science background at all, and
I too.
I'm from a history background, so that's a completely different, far removed from what you were saying. Many of the things were Greek to me, so that's a different thing. But what I was more concerned about was the absence of the notion of the invasion of privacy. I mean, you drew a very rosy picture of data science, data collection, and you gave examples of FastTag, Google, and all that. But people like us who are very far removed from the technicalities of this whole statistics and things related to it, for us it's the things that concern more is the privacy of invasion. I was a little disappointed by the fact that there was not one. You didn't throw any light on that.
Well, I did not go into the details, but I touched upon that book which I mentioned is basically a kind of privacy, because what can go wrong and what are the consequences. In fact, that talks about how democracy is being affected by big data.
Right.
That book is actually about that, weapons of math destruction.
Right.
So it is actually a threat to democracy also. So in fact, that is basically talking about elections,
right,
and then how the big data is used for wrong the predictions and other things, or how it is badly etc. So there are problems. I mean, see, everything will have a bad side of that, and I did not propagate that this is a glossy thing. What I am trying to say that my intention is not popularizing data science here. My intention is like a statistics discipline was there for a long time. Almost now it is going to be 100 years, and the statistics is feeling a threat, and many of the statistics is becoming a data science. So what is the reason and why it is? So that is basically, I am not actually popularizing data science or anything, but
right,
the current the developments in information technology will sort of force everyone to think in this direction. Tomorrow you can see that even a bakery fellow or a shop fellow also try to have, because once the algorithm is stored in his mobile, he can even do it for his shop. This thing nowadays, big chains Amazon is doing. I mean, even Jio. In fact, the one which the project that I did, I mean, like that election thing. One student, two students were involved in that. One student is now in UK, is working for a big company, and the other student was picked by Ambani because he found that this is a good student. So I mean, he took him. So what I am trying to say that all retailers are using this particular one. Now everybody want to do business, so they want to have betterment of that. Well, there is a personal side of that, privacy, secrecy of the, I mean, like all these things. But I am not an expert to comment on that in more detail. I am really sorry.
no problem.
Any more questions? Well, if there are no questions, thank you very much for giving me an opportunity to share some
Hello,
of my
sir.
thoughts.
I hope you can hear me. Yeah, adding to what Dr. Anmol has just asked, I'm a books that you were referring to, the reviews of them. And I think one also needs to maybe think about philosophy and ethics when one is talking about data science or statistics in general. And this has been a question that statistics has been dealing with for quite some time. For instance, the employment of statistical methods to study social science. And particularly when mind compromising to the demands of the industry, I find it a little problematic when academicians make such statements. In Homo Deus, for instance, Yuval Noah Harari talks about the issues with the humans and of data science in particular, to not just not but using moving from predict to prescription, that becomes an even more of a issue. So when we're talking about it and when you're only talking about the advantages of it without touching upon the disadvantages. For instance, you were showing us the tweets of Narendra Modi and Rahul Gandhi and calling some of them positive and some of them negative. What would be the parameters? So without having a social scientist on the panel, for instance, without having a without having a philosopher, without having someone whose expertise is ethics on board, if we employ data science, particularly for the study of societies and social phenomena, how appropriate would it be?
Yeah, so it's not the problem of data science only, because any research requires ethical, confirmation. So earlier also these ethics committees were there, and it is mandatory in any kind of research, because especially the research which is affecting human beings, you require not only human beings like animals or anything, I mean, like, you require ethics committee on that. So I don't think there is any difference in now also, because this is also another area of development and research. So you have to have an ethics committee. I mean, if you are actually getting into the privacy, then that needs to be discussed, definitely. But here I am not actually talking, that's not my topics, and I am not an expert in that. So I don't have any specific comment on that. Because recently I think the WhatsApp thing was also like, it's a big issue. So privacy, data privacy and other things. Well, that's not interest at the point of time, because my topic was very clear, like I want to make a connection between the statistics and this thing. And statistics research, as well as any other research, also deals with ethics, because with every university has an ethics committee. Any research proposal should go through the ethics committee. Perhaps, I don't know whether you are aware of it, whether it is even our, even with numbers or whatever that you are doing, that has to have an approval of ethics committee. So that's always there. You have to